Welcome back, Logan, to another installment of Geometry from Your Couch. We're going to jump into the topic of arcs today. So we're going to pretty much start where we left off on the last video. And what we have is a picture of a circle where you have 2 points on the circle. The 2 points that we have are A and B. And the question that I have is, if I was to ask you to highlight arc AB, which arc would you highlight? And I'm pretty sure the majority of us would end up highlighting this arc here, the one that I've highlighted in yellow. However, there are some of us that might highlight this one, this blue one here, and this can cause a problem because these two arcs are obviously different. They're not the same. And it would be confusing if I was to say, everyone look at arc AB, and some people would highlight the blue versus highlighting the yellow. So what I want to do today is talk about the difference between these two arcs. And to do this, I need to introduce a third point, and that is point C. So what I'm going to do is I'm going to introduce the third point, point C, so that I can now talk about these two arcs. So now the idea is, if I was to give you two letters, just A, B, our assumption must be that we are talking about the smaller of the two arcs, the shortest path between those two arcs. So that's this guy right here. So when I talk about arc AB, that is a smaller arc. This is what we're going to call the minor arc. So in this scenario, arc AB is the minor arc. However, there is an additional arc that starts at A and ends at B, or starts at B and ends at A, but it goes around the other path. Now, to name this arc, rather than using just two letters, I'm going to use a third letter. I'm going to use letter C between the two. Notice that both my yellow and my blue arcs start at A and end at B. However, the blue arc has an added letter, has an added point that it passes through. Now, because the blue arc is larger than it's more than half the circle, we're going to call those major arcs. So when the arc is less than half the circle, we'll call them minor arcs. And then when the arc is larger than half the circle, we're going to call those major arcs. In other words, less than 180 is a minor, and larger than 180 is what we're going to call a major. All right, now there is another thing that can happen, and that's if I was to cut the circle perfectly in half with a diameter. So if I was to draw a diameter splits the circle into two congruent parts, two congruent pieces. So we're going to have two arcs now that we need to discuss, and those two arcs are arc CAD in purple and then arc CBD in green. Now you'll notice that both of these two arcs, the purple arc and the green arc, both start at C and both end at D. However, their middle letter, the point that they pass between, is different for both of those, and this is what defines the two arcs. If I'm talking about CAD, we would all look at the purple arc, and if I'm talking about CBD, we're going to be talking about that green arc. Now, these two arcs are examples of semicircles, and that's because that they go exactly, 180 degrees. And if you're going to go through 180 degrees, then we're going to call those semicircles. Okay, so now we have these three types of arcs. We have the minor arc, less than 180, the major arc, more than 180, and then the semicircles, which are exactly 180 degree measurements. The next topic is the topic of the arc addition postulate. Now, what this postulate essentially says is that if you have two arcs, xy and yz, that are adjacent to each other, that means next to each other, then you can add them up for the total sum of those arcs. So here's our example. Suppose we have right here, arc xy is 43. So if I wanted to, I could write a 43 right here. And I also have yz is 49, so I could write a 49 right there. The question then is how long, or what is the measurement, sorry, not how long, that's a different thing. What is the measurement of arc xz? Now, what the postulate states is that if you were to take xy, so if you were to take the arc xy, and then go ahead and add it to the arc yz, their sum should equal all of measurement of arc xz. Okay, so this piece plus this piece must add up to the entire piece. So now I can just substitute those pieces in. I have 43 degrees here, and I have 49 degrees here. And if I was to add those two things together, that's going to give me the measure of arc xz. Oops, sorry, I meant to put a z right there. The measurement of arc xz. Now, if I add those together, what I end up getting is 43 plus 49, which comes out to 92 degrees. So I get a total of 92 degrees by adding the 43 and the 49 to be 92. All right, let's take a look at a second example. Now, our second example, what we have here is we've got something very similar, except this time yz. Okay, so yz goes from here to here, that's 53. And then we know that xz, or zx, this whole thing right here, comes out to 98. Now, This one, the way I'm going to write this one out is I'm going to say that if I add xy, so if we take the xy arc and we add it, all right, the little measurement symbol, and I add it, the xy arc to the 53, notice I'm skipping a step here. Rather than substituting in a second step, we're substituting all at once. That should have a total sum of 98 degrees, the entire arc right there. So now I can solve this by subtracting the 53 from both sides, and this gives us the measurement of arc xy is equal to 45 degrees. So if I was to take this 45 here and add it to the 53, I should get a total sum of 98 right there. All right, on to our last example. Now, our last example is a little bit more complicated, and it requires us to think about the definition of the measurements of the arcs. So for this one here, what is the measurement of arc XW? What's the measurement of this thing? Remember, the measurement of the arc is essentially the measurement of the central angle. So this arc right here has a measurement of 100, which means that from W to Y, we'll have a total of 150. So all the way from W all the way through Y should be 150. All right, so what is the measurement of XW? That's going to be 100, so I'm just going to write 100 degrees right there. Now, what is the measurement of YZ? This thing right here. If WXZ, okay, I know I need to go W to Z, but I need to have X between them, and X is not between them here, so that must mean that it's going to go around in the other direction. So what I'm going to do is I'm going to say this is what we're going to focus on right there. So that whole arc right there has to have a total of 210. So what we're going to do is we're going to say I know from W to Y is 150. So W to Y is 150. I don't know what Y to Z is, but I do know that if I add it, right, if I add that arc to the 150, that should come out to 210. And if I subtract the 150 from both sides, the result will be that the measurement of arc YZ is equal to 60 degrees. So we now know that this arc is 60 degrees. All right, take a look at the assignment. It should look just like this. It's going to be asking you what is this a minor or major, or is it a semicircle? And then ones where we're dealing with the arc addition postulate. If you have questions, go ahead and hit me up on email. Hope to talk to you guys really soon.